scenario of katakoda GitHub Git controlling Git version controlling practical series. Going to start the fourth scenario. It's about undoing changes. It shows how to undo changes when required. Going to enter the scenario. In here, one of the main advantages when using version control system is the ability to undo changes and return to previous version. Git provides powerful approaches and control over managing your repository and its history, which we'll explore in this scenario. In this scenario, the environment has been created with Git repository with a number of simple commits. I'm going to start the scenario. The first step is Git checkout. When working with Git, a common scenario is to undo changes in your working directory. The command git checkout will replace everything in the working directory to the last committed version. If you want to replace all files, then use a dot to indicate the current directory. Otherwise, list the directories files separated by spaces. Use git checkout to clear. Let's see. The second step is git rest. If you are in the middle of commit and have added files to the staging area but then changed then you will need to use git reset command. Git reset will move file back from the staging area to the working directory. If you want to reset all files, then use to indicate current directory. Otherwise list the files separated by spaces. This is very useful when trying to keep your commits small and focused, as you can move files back out of the staging area if you have added too many. Ask move changes from from staging back to the working directory. Git reset. This is the command to get back to the working directory. Let's see what's git reset. Okay, right. Git reset. The third step is git reset hard. A git reset hard will combine both git reset and git checkout and single command. The results will be the files removed from the staging area and the working directory is taken back to the state of the last commit. Remove the changes from the both staging area and the working directory. Git reset using head. Using git reset and alias for the last commit. Git revert. The fourth step is git revert. If you have already committed files but realized you made a mistake, then the command git revert allows you to undo the commits. The command will create a new commit which has the inverse effect of the commit being revert. If you haven't pushed your changes, then git the last commit. Last commit. Git revert changes in the last commit. This will open VIM editor session to create a commit message for each commit to save the commit. Quiet VIM type command behind creating new commits. The fifth step is git revert. To revert multiple commit at once, we use character to mean minus. For example, head to from the head. This can be characters to say between two commits. Use the command git revert. Use command git log for quick overview of the history. This scenario demonstrated how you can reset and revert changes you have made and how to go back to previous state. This scenario has been added to your scrapbook where you can review the examples and commands you executed. And that's the end of fourth scenario. Going to start next scenario, the fifth one. That's about fixing merge conflicts. I'm going to start that one. Uh, in this scenario, you will learn how you can share the changes in your repository with other peoples and combine their changes in your own repository. To help complete this scenario, a repository has been created with a remote repository attached. The environment has simulated that another developer has worked on the same file as you. As a result, when you pull their changes, you find that conflicts between both of your changes. This scenario explains how to resolve this conflict. The first step is git merge. The git fetch command download changes into a separate branch. Checked out and merged. Combine the commits. When no conflicts exist, then the merge will be fast forwarded and you won't have to do anything. If a conflict does exist, then you will retrieve an error repository will be merge state. In your environment, the changes from remote repository has been fetched. You now need to merge the changes from origin master. This will result in a merge conflict. The conflict indicates the merge failed because both repository had the steps. By keeping commits small and focused, you reduce the likelihood of merge conflict. Git pull is combination of fetch and merge. Weaving conflicts. Weaving conflict. When a conflict occurs, the changes from both the local and remote appear in the same file. The Unix diff format. This is the same format used by gitdiff. To read the format, the local changes will appear at the top bit page. Remote changes being the resolve the conflict. Files need to be edited. The third step is resolving conflict. The simplest way to fix conflict is to pick either the local or remote version using chip checkout. If you need to have more control, then you can manually edit normal. Once the files are in the state desired either manually or using chip, then you need to stage and commit the changes. When the committing a default stage will be created with the details of the merge and which files conflict. Uh, Resolving the conflict by selecting remote changes and using Git to revert in the middle of a merge. Git reset state. Use git commit to default commit messages. Stage text. Check out the staging text. Non-fast forward. To simulate non-fast forward merge, pull number one, developer pulls the latest changes from developer B. Developer A pulls the latest changes from the developer B. Developer B commits local repository. Developer A commits non-conflict changes to their local repository. Pulls the latest changes from the developer B. This scenario it is unable to fast forward. Synchronization points between repositories but also produce a noisy commit log. In the next step, we'll investigate alternative approaches. Pull the changes from the remote repository and use the default commit below. Git pull. You can view the commits with it log on. The fifth step is git rebase. The merge commit mergers can be useful to indicate synchronization points, but they can also produce a lot of noise. For example, if you are working against local branches and haven't pushed, then this additional information in meaningless and confusing to other developers looking at the repository. To solve this, you can use Git rebase instead of git merge. Git rebase git merge. A rebase will unbind the changes you have made, replay the changes in the branch, applying your changes as if they happened all on the same branch. The result is clean history and graph for the merge. Important as rebase. Will replay the changes instead of each commit will have a new hash pushed. Base commits that have been, for example, pushing commits, then rebasing in all the commits from a different branch. The result will be previously public commits having a different hash. More details can be found at the sixth step is rebasing pull request. This approach also applies when working with remote branches and can be applied when issuing a pull request using this cheat pull double minus rebase. This will act as if you had done a pull request before each of your commits. Uh, in this scenario, we have explored the different ways to handling merges. We have seen how to use JIT fetch and JIT merge to pull remote changes, how to resolve conflicts with other commits, and finally how to keep our JIT clean using JIT rebase. Merging is an important part of JIT, a topic we'll explore in more depth in future scenarios. That's the end of fifth scenario. I'm going to start the next one. It's sixth one. That is experiments using branches. In here, we are going to learn how to create branches of master for experimenting and prototyping ideas. Going to start the scenario, the sixth one. Uh, in this scenario, you will learn. In this scenario, you will learn how you can create branches in your repository. A branch allows you to work in effectively and brand new working directory. The result is that a single JIT repository can have multiple different versions of the code base, each of which can be swapped between without changing directories. The default branch in the JIT is called the master. Additional branches allows you to perform the same operations and commands as you would on master, such as committing, merge, and pushing changes. As additional branches work in the same way as master, they are ideas for prototyping and experiments, as any changes can be merged to master if required. When you switch branch, JIT changes the contents of the working directory. This means you don't need to change any configurations or setting to reflect different branches or locations. This environment has been configured in the repository with remote origin repository defined. Then I'm going to enter to the scenario. It has 5 steps. Mm, the first step is JIT branch. Creates are created based on another branch, generally master. The command is JIT branch, new branch name, starting branch. Takes an existing branch and create separate branch to work in. At this point, both branches are identical. To switch to a branch, you use the checkout new branch name command. The second step is list branches. To list all branches, use the command git branch. The additional arguments minus "a" will include remote branches, while including minus "v" will include the head commit message from branch. List all the branches with their last commit message using this git branch va command. Third step is merge to master. A commit has been made to new branch to merge to master. Merge. The fourth step is push branches. As we have discussed in previous course, if you want to push a branch to remote, then use the command git push remote name branch name. The fifth step is clean up branches. Clean up branches is important to the amount of noise and confusion. To delete branch, you need to provide the argument. For example, git branch minus the branch name. It has been merged into a master. It is no longer required to keep your repository clean and understandable. It has been no longer required to delete your new branch. Mm, in this scenario, we have explored how you can work with branches, which are ideal for prototyping and experiments, as they can be quickly created and thrown away. This scenario has been added to your scrapbook where you can review the example and commands you executed. The, that is end of the sixth scenario.